So let's look at attempting to solve some equations that have trig functions in them. I think this is highlighted in section 4.7, but I'm not exactly sure. It's in chapter 4 somewhere. Let's solve some trig equations. Okay, let's start off with one just using one trig function. So let's solve the equation sine of theta equals 1/2.
Talking out loud. First, I thought you were by yourself talking out loud. Awesome. You might have been.
So I'm looking for all of the angles that if I take the sine of that angle, the opposite over the hypotenuse, that ratio is 1/2. So usually the best way to solve these is to draw a picture. Oh, and I should say that all of the trig equations that we're solving are over the interval (0 to 2 pi). Because really, I mean, there's an infinite number of angles that have that sine of that angle would be 1/2. So we're just going to look for a finite number of solutions on the interval 0 to 2 pi. So let's draw a picture here. Okay, so the mnemonic that I use that helps me remember in what quadrants sine, cosine, and tangent are positive and negative, and you'll hear me mention this in class, ASTC, and the little mnemonic is all students take calculus. So that just reminds me that all of the trig functions are positive in quadrant 1, sine is positive in quadrant 2, tangent is positive in quadrant 3, and cosine is positive in quadrant 4. So that just tells me where the particular functions have positive output values. Okay, so this sine function, it's a sine of theta equals positive 1/2, so I'm going to get an answer in quadrant 1 and in quadrant 2. So I'll draw my two triangles, and now I just need to label them with the opposite of side is 1, the hypotenuse is 2, and now I'm going to fill in the reference angles. Well, if the opposite side is 1, hypotenuse is 2, this is a 30, 60, 90, with the reference angle being 30. So that means my two answers here for theta are 30 degrees and 150 degrees. And in radians, that would be pi over 6, or 5 pi over 6. So there's two answers, and I just wrote the answers in both degrees and radians there. Okay, so let's just look at some more examples. How about the equation root 3 secant of x plus 2 equals 0? So usually we want these equations such that the trig function is isolated. So I'm going to subtract root 2 off both sides, and then divide by that root 3, and I'll get secant of x equals negative 2 over root 3. So, draw a triangle. So the secant of this particular angle is negative, so that means the cosine would also be negative, so I'm going to get answers in quadrants 2 and 3. So the hypotenuse is 2 and the adjacent is root 3, negative root 3. So that means it's a 30, 60, 90 with a reference angle of 30. So my answers for x are going to be 150 and 210, which is 5 pi over 6 radians and 7 pi over 6 radians. Okay, so let's look at a case where we might get a bunch of solutions, even more than 2 solutions. Let's look at the factor equation. cotan x minus 1 times the quantity 2 cosine x minus 1 equals 0. So this equation is factored. It has two factors, so Miss Maloney is bothering me over here, trying to make me laugh while I give my notes on trig equations. So I'm going to set each of the factors equal to 0 and solve each of those equations independently. Because if either of the factors here is 0, then the whole left side will be 0. So I need to solve cotan x minus 1 equals 0, and 2 cosine x minus 1 equals 0. Okay, so I'll solve the cotangent equation first. Just move that 1 to the other side so the cotangent function is isolated. So it's cotangent of x equals 1. So I'll make that 1 over 1. So this means that the ratio of the opposite side over the adjacent side is going to be 1. And I'll need to draw some triangles for this one. Okay. Well, cotangent is positive where tangent is positive. So that's going to be quadrant 1, where everything is positive, and quadrant 3. Again, I'm thinking all students take calculus, so tangent is positive in quadrants 1 and 3, as is cotangent. Okay, so the adjacent side is 1, and the opposite side is 1. So that's going to create a 45, 45, 90. Notice that in quadrant 3, both the opposite and the adjacent are negative, so that makes the ratio of them positive, because the ratio would be negative 1 over negative 1, which is just positive 1. Reference angles of 45 degrees, so that means that x is going to equal 45 degrees, or 225 degrees. And in radians, that would be pi over 4, or 5 pi over 4. Okay, so those are the two answers that satisfy the cotan x minus 1 equals 0. So now I have to solve 2 cosine x minus 1 equals 0. So I'll isolate the cosine x. So I get cosine x equals 1/2. I'll draw another picture here. So cosine is positive in quadrants 1 and 4. The adjacent is 1. Hypotenuse is 2. So that's a 30, 60, 90 with a reference angle of 60 degrees. So my answers here will be 60 degrees and 300 degrees. And in radians, that would be pi over 3 and 5 pi over 3.